This video will reveal everything you need to know about what lies ahead for your child in higher grades. You may believe that because your child excels at maths now, they will naturally continue on that path. However, this is far from the truth, and in this video, I will explain exactly why. Allow me to introduce myself and this project. Over the past 3 years, we compiled over 600 pages of notes for grades 10 to 12 and solved close to 10 years worth of past paper questions in every section to prove that everything that we have is as comprehensive as possible. This information is free on our YouTube channel, and we provide you with support from Monday to Friday. In grade 10, I achieved an average of 97%, followed by 95% in grade 11 and 94% in metric. I went on to study first year biomedical engineering at Wits University, where I earned distinctions in Math 1042 and Math 1043. I worked closely with parents, students, and teachers, and their transformative results after engaging with our content speaks for itself. Their reviews highlight the impact and effectiveness of our methods. Now let's delve into the essence of this video, the critical flaws in our current maths education system. I've broken this down into 3 main parts, and I've included proof throughout to verify everything that I share. At FPT Mathematics, we firmly believe that distinctions are overrated. I even dedicated an entire video to explain why this is one of the rare cases where numbers can be misleading. Now let's move on to these 3 main points. Point number 1, the over-reliance on calculators. In first year accounting and engineering courses at renowned universities, students are not allowed to use calculators during exams. These are real exam papers from these institutions, and they prove exactly that point. Let me challenge your child's understanding. Have them factorize these 2 questions, once without a calculator and once with a calculator, and the results might surprise you. In the first case, you can see that without using a calculator, we actually yield the correct answer. But with the use of a calculator, the answer is incorrect. And there's certain specifications that teachers are supposed to mention to the students that they don't. And because of the incorrect way that the syllabus is relayed to the students, they do not teach them this idea when using the calculator. In the second question, you can see that both methods do yield the exact same answer, but there's foundational steps that the student lacks that they require at higher grades, and this is why we have the current problems that we do at university that I will highlight at the end of the video. Point number 2, the importance of a strong foundation. Grade 9 teachers teach grade 9 students. There are topics taught at grade 8 and grade 9 by teachers that understand the work very poorly, that is revisited at higher grades by teachers that do understand the work. And all of the foundational explanation is left untalked about for 3 to 4 years. And eventually when your child reaches university, when all of these topics are talked about collectively, they have the slightest clue of what's happening because of the lack of the foundational explanations at lower grades. This is why I do not agree with having grade 9 teachers teach grade 9 students. You're supposed to have a grade 12 teacher teaching grade 8s and grade 9s because that's when they can adequately prepare you for higher grade maths. To emphasize the value of foundational knowledge, here's an example of a mind map we created for grade 10 students in term 1. This mind map highlights 2 key aspects. It gives students foresight into what to expect at higher grades. This is a grade 10 mind map. I've already talked about what topics they should expect at grade 12 and grade 11. And the second thing is that it connects every section. So teaching them as a whole rather than an isolated fragment. So I've already linked a grade 12 topic to a grade 10 topic just by drawing this informative mind map. And this will enable your child to have a complete overview of what maths entails. This is why you cannot have a grade 9 teacher teach grade 9 students, because they cannot make the necessary links to higher grade maths. To further emphasize my point, have them simplify this question. The natural step that every student take and every student is taught to do is factorize the numerator and denominator, and this is the answer that they do yield. The incorrect answer, x plus 6. And the reason that this is the case is because teachers don't talk about having the restriction for these types of questions. And it's only talked about at semi-private or private schools and at university. And this is actually considered correct at secondary school, which could be detrimental at higher grades. This is why having a solid foundation at lower grades is very important. We even provide the explanation as to why we say this. So we do not teach maths just with facts and theories. We prove them. We prove them for your child. Point number 3. Misaligned priorities in teaching. Many teachers prioritize metric pass rates to attract more students to their school, often at the expense of quality education. They simplify the syllabus, skipping critical foundational explanations necessary for success in higher grades. This approach has long-term consequences reflected in South Africa's alarming university dropout rate of 60%. When teachers become so obsessed about the metric pass rates, they water down explanations to avoid confusion, and they do not make connections between topics. Because when you make connections between topics, if you cannot start the story good enough, then at the end of the maths journey, it becomes very confusing. So giving them that incorrect foundation at grade 8 and grade 9, when they go to higher grade maths at grade 12, teachers have to intentionally leave out important pieces of information, as this could confuse students even more. This is why building the story from the introduction to the conclusion is very important. If there's one thing you take away from this video, let it be these 3 critical points. Over-reliance on calculators prevent true mathematical understanding. A strong foundation is key to higher grades and beyond. Prioritizing pass rates over quality teaching leads to long-term failure, as evidenced by the university dropout crisis. And let me remind you, what's right is right even if no one is doing it, and what's wrong is wrong even if everyone is doing it. You have access to premium information that could save your child 1 year, 50,000 Rand, and needless effort. Do not be one of the 60,000 students that drop out of university. This is bigger than just academics.